Here we have a 16 kilogram block attached to a cord that is wrapped around the rim of a flywheel of diameter 0.4 meters and hangs vertically. So the rotational inertia of the flywheel is given by 0.5 kilogram meter square. So when this block is released from rest and the cord unwinds, what is the acceleration of the block? Okay, so first we note that our flywheel has a moment of inertia. So a net torque must be applied for it to undergo a angular acceleration. And that net torque will be coming from the tension provided by this block. So here we have a tension. Let's draw it here. So we have a tension here, and this tension is also felt by the block. Also, we note that the block has a weight here. Okay, so to solve for A, we have two mass systems. So we will need two equations to describe the acceleration. Okay, so our first description will be in the flywheel. So we will describe it in Newton's second law of rotation. So we know that the net torque acting on an object is equal to the moment of inertia of an object times its angular acceleration. Okay, so inside this angular acceleration, this is actually defined by the tangential acceleration equals alpha times r. So we can define alpha to be our tangential acceleration over r. Now this tangential acceleration is the A that we want to solve here. Okay, so let's write this to be I times A over R equals the torque, the sum of the torques needed for the flywheel to rotate. So we also note that this torque should follow the same direction as the tangential acceleration. So here for our twisting force T, we have an R. The direction of tangential acceleration is downward. So this tangential acceleration will be provided from this twisting force. So we will assign this twisting force to be positive. Take note, this is just a matter of convention. Okay, so here we have the effective force times the moment arm, which is the radius of the flywheel. Okay, so solving for T, we get I over R square times A. So this is our description for the flywheel, or our set of equations for the flywheel. So now let's describe the block. So we can describe the block by Newton's second law on linear mode. So we have the net force acting on the block equals the mass of the block times its acceleration. So we have weight of the block minus the tension. Let's just put magnitudes. So here we have mg minus t. But we also know that the tension here is the tension in here. So we substitute t's. We get ma equals mg minus I over r square times a. Next, we group the acceleration term. So we have ma plus I over r square times a equals mg. So factoring out a, we have m plus I over r square equals mg. So now we solve our acceleration. So this is mg over m plus I over r square. Okay, so putting in the values, we have a equals 16 kilograms times g all over 16 kilograms plus I. So I is 0.5 and r is 0.4 meters. Over 0.4 sorry, this is diameter, so this should be r, this should be 0.2 meters square. So our acceleration is 5.5 meters per second square. Now take a look at this equation. So let's ask what if our pulley is massless? So if it is massless, it will have zero moment of inertia. So this will be 0. So our acceleration will be a equals mg over m. Acceleration is g, 9.81 meters per second square. So what we have here now is a object in free fall. It's like saying that this flywheel has no effect on the motion of this object. That's why it is in free fall.